I have here is to separate in 4, 1, 2, 3, 4, in 4 fractions. This is a very important technique for the next calculus class. Very important technique. So when you see something like this and only one term, do not attempt to simplify anything. That will be a tragedy. But what you can do is write x to the 4th over x squared minus 3x squared over x squared minus 4x divided by x squared plus 7 divided by x squared. And you can say, what kind of division is this? What did you accomplish? A lot, but not necessarily for this class, but for the next one coming up in the spring. So each individual fraction can be simplified. Not all of them, but x to the 4th over x squared is x squared. 3x squared over x squared is minus 3. 4x over x squared minus 4 over x. And the last one has to stay. And you can say, what did you accomplish? And the answer again is a lot. But you have to wait to see why later on. So if it's a polynomial divided by one term, this is what we need to do. And you can say, this is not a real division. I would have to say you're right. It's not. But it's the only way we have. The only available way, and it's a very important. It means a lot in the next class, in the spring when you take calculus. Okay, so remember that. Now, when we have, which page am I on? I'm on page 10. Now, when we have something like this, a polynomial divided by x minus a. What does this x minus a mean? Examples. X plus 2, x plus 3, x minus 4, x plus 1/2, x minus 2, and so on and so forth. X minus a number. In this case, a is negative 2. In this case, a is negative 3. In this case, a is 4. In this case, a is negative 1/2. In this case, a is 2, and so on and so forth. This division can be calculated using long division or synthetic division. Both work, and I'll show you both. In general, something like x squared minus 3x plus 1, this can only be addressed using long division. Only long division. Synthetic division has limited applicability. Only if the denominator is of this form. If it's x squared minus 3, you cannot use synthetic division. So it has to be a linear factor. And if the leading coefficient is not 1, then a little trick is required for the synthetic division. Long division always works. Not in this case. Okay. So let's illustrate a synthetic division. So I picked the first one here, and then I'll let you pick the next one. So 3x to the 3rd minus x squared plus x minus 2 and divided by x plus 2. So remember, all terms have to be in descending order. So we are going to look at synthetic division. For synthetic division, we create a little box, and in this box we have to put a. Because it's x plus 2, a is how much?
-2.
Excellent. All these are in descending order, degree 3, degree 2, degree 1, and degree 0. I only copy the coefficients. If 1 is missing, I have to copy 0. In this example, no coefficient, no term is missing. 3. Next one in line, negative 1. Next one in line, 1. Next one in line, negative 2. Leave some room, draw a horizontal line. Copy the first coefficient no matter what. Now we start the synthetic division. Negative 2 times 3 is negative 6. And we write above the line under the next coefficient. Perform the operations we see. Negative 1 minus 6 is negative 7. And we continue in the same way. Negative 2 times negative 7 is 14. Write it above the line under the next coefficient. 1 plus 14 is 15. Negative 2 times 15 is negative 30. Write the answer above the line under the last coefficient. Perform the operations. Negative 32. Box it in. This happens to be the remainder. So, the answer, quotient plus remainder over the divisor. Quotient. Oops. Quotient. Remainder. Divisor. How do I write the answer? Again, I'm using the triangle and jumping to the next page. 11. Quotient. How do I know? Well, I divided degree 3 by degree 1. So this must correspond to x squared. Minus. This must correspond to x. And this must be the free term. So I copy the quotient. Now I have to write plus the remainder. But since the remainder is negative, I'm going to write negative 32 over the divisor. X plus 2. Quotient, remainder, divisor. How do I know that this is correct? Very easy. I multiply x plus 2 by these 3, like x plus 2 times 3x squared, minus 7x plus 15. Subtract 32. If I do not get the numerator, 3x to the third minus x squared plus x minus 2, then the whole thing is incorrect. I start from scratch. So, this is my quotient. I multiply it by the divisor, and then I subtract 32. If I do not get the numerator, what was the numerator? 3x cubed minus x squared plus x minus 2. My answer is incorrect. So let's do that. X distributed here, 3x cubed. X distributed here, minus 7x squared. X distributed here, plus 15x. 2 distributed here, plus 6x squared. 2 distributed here, negative 14x. 2 distributed here, plus 30 and minus 32. 3x cubed? Yes. Negative 7x squared plus 6x squared? Yes. 15x minus 14x? Yes. 30 minus 32, negative 2? Yes. So it's yes, and it's yes. The quotient is indeed 3x squared minus 7x plus 15. The remainder is indeed negative 32. Any questions? Any questions on how to apply the synthetic division?
Where did the negative 2 come from before you keep on?
You mean this one?
No, at the dividing.
Oh, the negative 32?
No, the negative 2. Sorry about that.
Right here. Negative 32 plus 30. Is that okay? So 3x cubed, negative 7x squared plus 6x squared, 15x minus 14x, 30 minus 32.
I'm referring to the division application.
Oh, this one here?
Yeah.
Oh,
I'm trying to
okay. Very good.
rack my-
Because x plus a, I'm sorry, x minus a is x plus 2, which means a has to be negative 2. So the divisor is written like this to identify a. Synthetic division requires minus. If you don't have minus, it means that you have two minuses. So a is negative 2, because x minus negative 2 is x plus 2.
Okay.
Is that okay? Is that okay? Yes?
So A is negative 2 because I need to make sure that the divider is negative.
So if I divide a polynomial by x plus 2, a is negative 2. If I divide a polynomial by x plus 5, a is negative 5. If I divide a polynomial by x minus 1, a is 1. The denominator has to be x minus a. And based on this, I identify a. If I have x minus a, if I have x minus 1, by comparison, a is 1. If I have a plus 5, by comparison, a is negative 5. If I have x plus 2, by comparison, a must be negative 2.
Okay.
Is that better?
Yeah.
So in other words, all you have to do is show this. So x minus a equals x minus negative 2. So then this must be this. So a is negative 2.
Okay.
Otherwise you will not be able to identify the number in the box. So the number in the box is always a. But if you have x plus 2, then your a is negative 2. If you have x minus 1, then your a is 1. Any questions? Any questions? Okay, so I know we have only 4 minutes left. So let's make up a very simple example, like let's say x squared minus 2x plus 4 divided by x minus 1. So please use the synthetic division on this.